Going to tell a little story about arithmetic and geometric means. It's a little more than what's in the book. It's just a beautiful piece, beautiful pieces of algebra that relate to each other. So I want to remind you first of the ordinary average of two real numbers. And a fancy word for that is a mean. In fact, we want to say it's a special kind of mean, which is the arithmetic mean. The emphasis on the meh. So an arithmetic mean, just the ordinary average of two numbers, you're very familiar with this, just a plus b over 2. And so what's the number line picture for that? I take the average of two numbers, a and b, and that should be right in the middle of those two numbers on the number line. It should in fact be the midpoint of those numbers on the number line. It's a very nice connection to geometry already. So for example, if this a was 12 and b is 18, m is going to be 12 plus 18 over 2. That's 30 over 2 equals 15. So 12, 15, 18, plausible that that's right in the middle. But let me say one way that's special, that it's right in the middle. If I take the top one, 18 minus 15, that's going to be 3. So if this is going to be 12, 15, 18, then this distance is going to be 3. And that's also the distance between 15 and 12. That's actually exactly characterized as being in the middle, right? Being in the midpoint on the number line means you are the same distance away from the right endpoint, that's B, as from the left endpoint, that's A. Let me show you that's just always true for A plus B over 2, just a tiny little bit of algebra. If I take A, let's say I take B, and I subtract A plus B over 2, put it over a common denominator, 2B minus the quantity A plus B. These are parentheses that people often forget. 2b minus b is going to be a b, and then minus a over 2. Hey, let's see. So this is supposed to be the distance between b and m. And what we're getting is it's the distance between b and a divided by 2. Well, duh, it's the midpoint. It's chopping that in half. What do you get if you take a plus b over 2 minus a? It's a little bit of an easier calculation. A plus b minus 2a over 2 over the common denominator. I still get a b, and the a minus 2a is a minus a on the top. Hey, those are equal. And that's the general fact that these guys are equal. So one thing that's true about the ordinary average is that it's the same distance above the lower of the two numbers you're averaging as it is below the higher of the two numbers you're averaging. So we have two ways of characterizing whether you've got the right average. One is just the formula, combine the two numbers and divide by 2, add and divide by 2, or test to see if the number you think is the average has the same difference from the higher number as its difference from the lower number. So here's the thing, we can do that not with addition and subtraction, but with multiplication and division. So I'll have a little fanciful example here. So let's say I sell regular sporks at a price of $4 per box. My cousin Vinny sells premium sporks at a price of $9 per box. And my sister Susie wants to get into the action by selling some mid-priced sporks. Here's what she wants to mean by mid-price. She doesn't want to compare by the differences like we were just doing. She thinks it's more appropriate to look at the ratios of the prices, which is often a better way to compare things. So she wants the ratio of Vinny's price of $9 to her price, let's say P, to equal the ratio of her price to my price. And that's the $4. Let's see if she can do that. Let's see. And that is, in fact, a proportion. She wants $9 over P. That's by what factor is Vinny's sporks going to be more expensive than hers? She wants that to match the ratio by which her sporks are more expensive than mine. So hopefully you're getting a sense that's not too different from what we just did. We're comparing two numbers instead of by subtraction, but by ratios. And we want a mystery number that's going to be somehow in between 9 and 4, so that the extent to which 9 is bigger than this mystery number P is the extent to which p is bigger than 4, but in a proportional sense, not in a difference sense. Well, let's see what we get for that. You can, of course, cross multiply. 36 equals p squared. P is the square root of 36, and that's so $6. Now I set this up to be nice. The number is often going to be some ugly square root, but that's okay. We can live with that. But in this case, we can double check. 6 over 4, yeah, that's 1.5. And that's exactly 9 over 6 equals 1.5. So if somebody says to her, I don't know, I don't believe you're right in the middle, you can say, look, Vinny's sporks are 50% more expensive than mine. They're 1.5 times the price. That's exactly 50% more expensive. And my sporks, or that's this guy, and my sporks are 50% more expensive than Dr. Metzler's sporks. And that says in the sense of ratios, P is right in the middle. So P here is called the geometric mean of 4 and 9, or P equals 6 here. And we'll do the master formula in a second. It's going to be rather similar to what we saw before. Okay. And it's called geometric because these ratios will often come from geometry, because similar triangles lead to proportions, which often leads to this situation. And we're going to see in the next video about how this comes from specifically from proportions in right triangles and in other places. And so in general, okay. Oh, and one thing you might have thought, wait a minute, I thought we need a plus or minus. This kind of stuff about geometric means very rarely would be applied to negative numbers. And so we're only, and the book certainly, we are only going to apply this to positive numbers. And that's pretty common. It's just that restriction to only positive numbers. So the geometric mean of two positive numbers, A and B, is the number, let's say x, that satisfies this idea that B over x should equal x over A. Notice in the terminology of proportions, we've already been calling these guys the means, and we're just saying, oh, what if the means, plural, was just one number? What if they happen to be equal? Then it's going to be some special kind of mean of these two numbers. So that's why the notation is consistent. And in general, that cross multiplies to x squared equals AB, and x is the square root of AB. So there's the formula. If you just have two numbers and you want to do quickly, oh, what is the formula for the geometric mean? It's the square root of the product of those two numbers. I want to highlight the similarity to the arithmetic mean. Hey, this is the sum of two numbers, and you divide by 2. Okay, the more sort of complicated operation sort of up the ladder of complexity from addition is multiplication, and dividing by 2 really has a similar connection to addition as square rooting does to multiplication. So it's really quite analogous. And so this is really a very natural kind of alternate way of saying that x is in the middle of these two numbers, A and B. It will not almost ever give you the same number. In fact, it won't give the same number unless A and B are the same, in which case the arithmetic mean, the geometric mean are just that same number spit back at you. So fact, I won't prove that right here. It's not super hard to prove. The geometric mean is always less than the arithmetic mean unless A equals B, in which case A equals B equals M equals X all are equal. I take any kind of average in any general sense of two numbers that are the same, it's just going to spit back that same number. Okay. Okay, that's a good place to stop for here.